All right, guys, I'm going to walk you through another example of a law of sines ambiguous case. So your givens are that angle A is equal to 40 degrees, which is great because we need the given angle to be acute. We need its corresponding side, which is side A, to be 48.6 in this example, and the other given side has to be greater than side A in order for this to even be an ambiguous case two triangle possibility, which in this case side B is 52.4. So it is. So once again, just kind of reviewing. Angle A must be acute. Its corresponding side must be less than the other given side for two triangle possibility to even exist. So I told you guys set this up with the given angle in the lower left corner. So we're going to put that as our 40 degrees. Its corresponding side, obviously going across from it, and the other given side to be adjacent to the given angle. Because this is side B, angle B is the very first thing that we are going to solve for. Now this is in this situation where angle B is acute right in this particular spot. So because this is a two triangle situation, I'm going to set up a table and I'm going to say that we've got triangle 1 and we've got triangle 2. So let's go ahead and solve for triangle 1. In triangle 1, angle B is the very first thing that we solve for. So we set up my law of sines. Doing your cross multiplication, you get 48.6 times the sine of angle B equals 52.4 times the sine of 40. To get sine of B all by itself, you have to divide by 48.6. And in your calculator, to solve for angle B, you need to use the inverse feature and type things in as you see it. You've got 52.4 times the sine of 40. Make sure you close your parentheses after 40 because you want this entire numerator to be divided by 48.6. When you solve that through, you are going to find that angle B comes out to be 43.87. So we are saying right now in this picture that angle B is 43.9. Let's round it up a little bit. 43.9. After we found this angle B first using my law of sines, we then can very easily find angle C by doing subtraction from 180. So you've got 180 minus the given angle A, 40, minus the angle B that we actually found, and this comes out to be 96.1. Once we know angle C, then we can go ahead and solve for side C if this length was what we had as our picture. So I'm once again going to set up another law of sines. Do my cross multiplication. Get side C by itself. And side C comes out to be 75.2. Now just a quick check on my answers just to see if they make sense. Side C came out to be my largest side, therefore based on our hinge theorem, angle C should be my greatest. Angle A was my smallest of the three angles, so side A should be my smallest, which it is, and side angle B was my middle angle, so 52.4 should be somewhere greater than 48.6, which it is, and also less than 75.2. So as it is right now, my answers make sense. So moving on into triangle 2. This right here was your triangle 1. If we then by chance had a second triangle situation and we actually created an obtuse triangle, knowing that this was 48.6, this was our new C, side C of triangle 2, this is still going to be 52.4, this is still going to be 40, but this is going to be angle C of triangle 2. Instead of having it be, this is also an obtuse angle C, but instead of having an acute angle B, we're going to say that angle B of triangle 2 in this case is going to potentially be obtuse. And what we did to do that is we took this side A and we rotated it and connected it over here. I'll kind of put a little dash mark there. We rotated it, and although it doesn't look like it, we did create an isosceles triangle over here. That should be an isosceles triangle. And we see that we've got supplementary angles right here. Because this is an isosceles triangle, you also know that this angle right here is 43.9. This tiny little angle in there that I have no room to write in is this new B2. So based on the fact that we know that AB is a line and a line is 180 degrees, if this angle, because of isosceles triangle, because again we swung side A over here, so this side length was also 48.6. When side lengths are the same, their base angles are the same. We have supplementary angles. So we're going to use this information to solve for B2 by taking 180 and subtracting the angle that we came up with. This gets me my new B2, which is 136.1. Now, what I want you to do at this point, you need to stop and think. With your new B2, with B2 equaling 136.1, and your given angle A, because that's not going to change, equaling 30, is there room for angle C? If your two angles, when you add them up, are equal to 180 or greater than 180, there's no room for angle C. All angles in a triangle add up to 180. So if there's not even room, this triangle cannot exist. This triangle cannot exist if there is no room for a third angle in this. In this particular case, these two add up to 166.1. So in this case, yes, there is. So we find angle C. We find angle C of triangle 2. Taking 180, subtracting your angle B from triangle 2, and subtracting your given angle A, because that's not going to change. Your new C2 is coming up with, it's pretty small. This should not be a 30. This should come out to be a 40, so I am sorry about that. Your given angle was 40, not 30, so I apologize. We still have room. This is 176.1, so there's still room for C. It's pretty small. That's okay. Angle C is 3.9 degrees. So because angle C is very small, we know that side C is also going to be teeny tiny. So we're going to find side C from triangle 2 by setting up your law of sines. I tend to always use my given information instead of using B2 and side B, simply because I know that my given information is not wrong. So I set it up with the one matching corresponding pair that doesn't change. In this case, it's side A and angle A. I do my cross multiplication. Get C alone. And side C in this case comes out to be 5.14. You now have solved for all three angles and all three sides in both triangle situations, and you are finished.